Hey folks, how you guys doing? Hope you're all having a great day today. This tool talk video will be about CNC machines, primarily this one. This is an AR8 Pro Plus from Axiom, and not 100% about this particular machine. We'll sprinkle in some just general CNC information based upon some questions that I received, but primarily about this machine because I've had it for about a year and a half, and I posted an image of it on my social media and asked if you had any questions about it, and I'll answer them here in this video. A couple little caveats or asterisks before I get started. Number one, I hate giving tool recommendations. I understand that I have an online audience, and by default that means you're an influencer. But I genuinely dislike influencing other people's buying decisions because people's needs, wants, and desires change. And for example, when I got this machine, I was in a 2-car garage. This is a 2-foot by 4-foot cutting capacity, and it was probably it is the largest CNC machine that I think would be appropriate for that size space. Putting a large 4-foot by 8-foot CNC machine in a 2-car garage just wouldn't be ideal. Since then, I've moved to a much larger shop, and one of the two changes that I wanted to make regarding tools, the largest change was I wanted to upgrade to a larger CNC machine, and I've got the space to do so, so that's what I'm going to do. I'm going to upgrade to a larger machine, and before getting rid of this one, I figured it'd be a good opportunity to make this video so that we could at least have a little bit of information and documentation for other people out there to make a better educated decision for your specific situation. This may be the right machine for you, this may not be the right machine for you. I just want people out there that make a better educated decision for themselves rather than an emotional decision based upon some dude just drooling over tools on the internet, right? So that's caveat number one. The second thing is just a little bit of background information from my perspective with CNC machines. So I have used both ends of the spectrum. Really high-end, insanely awesome production machines in a production environment, all the way down to really not that impressive small little Chinese DIY kits. So first off, in the winter of 2010, 2011, I worked for about 6 months at Ashley Furniture in Ecru, Mississippi, specifically in their frame mill running a 4-foot by 8-foot Como CNC machine. I wasn't running any production stuff, but right next to me was the rest of the production environment. They had I think around 10 or 15 dual table Heian routers, and those machines were just so amazing and impressive. So on those machines, the X-axis was about 20 feet long, probably much larger than that actually, because inside that X-axis was 2 tables that moved for the Y-axis, and the tables had the 4-foot by 8-foot panels running lengthwise on the X-axis. So at any time, basically one table was pushed out towards the workers. There was a pair of workers pulling parts off the table, pulling the waste board off, or not the waste, the skeleton board off, and then putting a new piece on, and then that table shoots back into the machine. The gantry slides over to this table, cuts all this stuff out, while this first table that was previously cutting pulls back out, and the guys pull the pieces off. Super fast, high-end production environment. That was fascinating to watch, but that wasn't my job. My particular job at that facility was to run, they had a specific term for this machine and that position, but it was a hurry up and wait job. So basically my position was to supply the assembly lines with missing parts. So if this particular run of furniture required 40 pieces of this one particular piece and they have 38, something happened to 2 of them, 2 broke, whatever, they would send it to my station. My station will automatically print it out. As it prints out, I can pull up that item number in SolidWorks, import that into SigmaNest, and from SigmaNest, I had full control over where it was on the sheet based upon whatever sheet it needed to be out of, 18 millimeter plywood, 15 millimeter plywood, OSB, or there was 4 total. Anyway, So it wasn't always the same sheet at every time. If I had a half a sheet that was still available, but the material changed, I'd have to pull it off, put it on the rack, put one back on, and the piece that I put on may have been a half cut up piece, but I would still be able to pull open or open up that particular nest in Sigma Nest, and then put my new piece wherever I needed to, have complete control over the tool paths. This machine that I was working with had two Z-axis spindles. Well, one was a spindle, one was a drill. So you would drill your holes, it would drill the holes and then cut out around whatever you needed to cut out. You could bridge between pieces. Anyway, it's extremely fascinating. I really loved that job. That 4-foot by 8-foot Como CNC machine, the X-axis was fixed and the table moved in the Y-axis along the length of the panel. Vacuum table had rollers that held the piece down as well. And I'm rambling here, but as the piece was cut, I had just a short amount of time to get it cut and moved back to the line. So it was a hurry up and wait job. As something came in, I had to cut it real fast, but in the meantime, I had a lot of downtime to clean up around the machine, make sure my environment was nice and organized, and I had a lot of really good time to be familiar with the machine, and I learned a lot about CNC machines at that job. It was by far, hands down, the best job that I've ever had working for somebody else as far as interesting. It was just a really great experience working there. And I no longer work there because I got married and my wife was already established in another city, long story. So that's the high-end side of it. After that, started doing woodworking here and got I think it was the Shapeoko 2 CNC machine, real small machine, I think like a 12-inch cutting capacity, 12-inch by 12-inch cutting envelope, powered by a Dremel, exact opposite of what I was already familiar with. Didn't have that for too long, and then Inventables came out with the X-Carve, which is somewhat the third version of the Shapeoko, but rebranded. And when I got it, it was still early on in the development stages of the X-Carve. A lot of things were not buttoned up, and it's nowhere near as, I guess, polished as the current X-Carve model is. I didn't use it for too long. I just wasn't really impressed with that machine at that time. The software was a little bit limiting. I didn't have the software that I have now, which is much more powerful. It wasn't interesting for me to keep, and I did a giveaway on my website, passed it along. After that, I think it was this one. I don't think there was anything in between. I got this one in October of 2018, and I've been really impressed with this one. The speeds, the feeds, the cutting capacity, the reliability, the ease of use, and of course the software that I'm using now, VCarve versus at the time Easel, and I think it was MakerCam. Much more streamlined, much more easy and convenient to use, and I've really put a lot of use on this machine. Whew, that was kind of like a rambling introduction. This video may be really long, but I'm gonna stop here and get into the questions. Some of these questions may overlap slightly, but I'm just gonna run through them all. How square does it cut? Have you measured that? How is its accuracy in relation to what it claims to be, basically? So I've only tested the accuracy of this one time. Basically, if your gantry is not square to the y-axis, you're not going to cut square. You're going to cut a parallelogram, and that's bad. Obviously, you don't want that. So I only tested it one time. I took a large piece of plywood, drilled 3 holes at a right angle on the software, and inserted these metal dowel pins, which are really, really handy for various tasks, and used my largest precision square that I have, which if I'm not mistaken is like 16 by 28, something like that. And the largest precision square that I had was touching on all 3 points at a right angle. So that's the only time I measured it, like probably a year ago, and I haven't measured it since, but at that time, all 3 of those points were touching, so it was as accurate as my precision square said it was accurate. I haven't had no reasons to test it again or question its accuracy since. Does it have a lathe attachment so you can do wood turning on the CNC? This particular machine, I do not have the 4th axis rotary attachment. So those are called 4th axis attachments. So a CNC machine like this has your X travel, in my case, my left to right, my Y travel, which is front to back, Z travel, which is the bit plunging into the surface. So that's 3 axes. The 4th axis, is a rotary attachment, and where you have another motor that controls its rotation while you still have all 3 axes in play of cutting around that rotation. In this machine, somewhere on the left side of it, there's an attachment that the tailstock can go into these slots on the table, and then it goes to the headstock goes in the back side over there. It plugs in. This is set up for plug and play 4th axis. You just set it in place, plug it in, calibrate it. I've never used or had the attachment for this particular machine, but it is available. If you were purchasing one today with the knowledge you have gained over the last year and a half, would you buy the same one? If not, what would you purchase and why? So if I was starting over, I would probably get the same one. And if I was in the same situation that I was in, that's the big caveat there. So in my case, my environment that the machine went into played a huge role into the limitations of what I could get. So with that said, I'd probably do the exact same thing if I was in that exact same situation, because there's absolutely nothing negative. I have no negative experience with this machine for me to want to look elsewhere and go with a different setup. So yes, I would probably get the exact same one. How much was it, and do you think it is worth the price? The worth the price part is completely objective for the most part. Most everyone's going to have an objective opinion on is it worth the price, and those are opinions. So nobody's wrong because it's a personal opinion. If you don't do production work or don't think you would use a CNC machine or whatever, you're probably gonna think it's not worth the price. I don't do automotive work at all, so a guy down the road with an automotive shop and a $2,000 or $3,000 car lift, or however much those are, may think that that lift is completely worth the price. I don't. So from a opinion perspective, it doesn't matter. But from a business perspective, this machine is very capable of paying for itself very fast if you put it to work. What is your design to G-code workflow? What software do you use? How is the noise level? Do the runs take a long time to complete? And what is the cost in kilowatts or dollars per hour? I've never measured the electricity. This doesn't pull much electricity. It requires a 240 volt circuit with a 10 amp 240 volt circuit. It doesn't use much power at all. What is the noise level? The noise level of the machine itself is not that loud. So I just turned the spindle on. So without it cutting, this is the machine running at, let's see, there's a conversion chart I printed out. This is about 18,000 RPM. It's much quieter than a router, as you notice, but it's also just free floating in air. It's not cutting anything. That's where your noise is going to be, is when it cuts to the material, which is going to be about the same regardless if you're using a router or a spindle. So it by itself is pretty darn quiet. That being said, I'm running dust collection every time I run this thing, so hearing protection is required for me working here in the shop. The noise of the environment, the other stuff going on, will trump the noise of this machine. A true spindle is much quieter than a router, and I will give a recommendation there. So I do not want to be around a screaming router for many hours on long cuts or a long time. Typically speaking, spindles are much quieter and more precise and longer lasting than routers. You can use a router in a CNC machine, obviously. So many people do with good results. But I'd be willing to bet that burnt up routers are way more common than burnt up spindles. And then also the noise level is just tremendously night and day difference. This is a liquid cooled spindle, which I think someone else answered or asked a little bit down the road. What software do you use? What is your design to G-code workflow? There's a lot of options out there. The workflow that I am most comfortable with, most efficient with, is designing all of my stuff in SketchUp, because I'm very, very fast and efficient with SketchUp, those designs can be just drag and drop imported right into VCarve. VCarve is a great CAM solution, the toolpath side of things. So that's where you take your design and you create your toolpath. Now you can do complete 2D drafting and design work and even light 3D stuff in VCarve, or 2.5D is what it's called. But for the most part, design in SketchUp, tweak minor adjustments, and do all the tooling in VCarve, and then export on a flash drive to this machine, which I'll get into in just a little bit. There's a controller over here. So you don't necessarily have to have three steps involved. You can go VCarve right to this, or you can use Fusion 360 if you want right to this. I like VCarve. Is this something you would recommend for a hobby woodworker that would mainly be interested in template making with the occasional engraving or whatnot? Or do you think this is more suitable as a production CNC? Both, really. So this is plenty capable of being a production CNC machine. As a matter of fact, my good friend Jonathan Katz-Moses has the exact same CNC machine, and he puts his to work constantly making stuff for him. So he's using his as a production CNC machine. On the other side of things, which is basically what the category I would fall into, is would you recommend it for a hobby woodworker that would mainly be interested in template making or the occasional engraving? With CNC machines, you're getting precision, right? So what I use this for, and something that has really paid off financially for me, is to use this machine as a way of prototyping with precision. You can cut out prototypes and work out all of the bugs and figure out a product. For example, I make templates to sell, and I have designed several different iterations of a few different templates, settled on a final design, and then sent those designs off to somebody else to do the production work on them. So while I'm not using this as a production machine, I am taking advantage of the whole production cycle by being able to prototype with it and have somebody else do the order fulfillment and cutting and all that stuff. So it's best of both worlds. If you want it to make money, it's going to make you money if you put it to work. If you want it to just do hobby stuff, well then, if you justify the purchase, then it'll do the hobby stuff just fine. What makes these higher priced machines cost more than the Xcarve or Shapeoko? Well, first off, CNC machines, what you're getting with CNC machine is precision, and the Xcarve, the Shapeoko, the long mill, Bob CNC, some of those CNC machines in that price point, majority of those can cut the same stuff that this can cut. This thing can cut, for the most part, the same things that a $20,000 CNC machine can cut. So what you're really, the main thing that you're getting when you jump up a class in CNC machines, because there's super cheap ones, there's a little bit more expensive ones, there's even way more expensive ones. What you're paying for is the level of durability, the level of maintenance, speed, efficiency, long-term stability, and it's just finding the right price point for what you value. So the Xcarve and the Shapeoko can cut all of my stuff so long as it fits on that particular cutting envelope. What you're getting with, say, this versus the Xcarve or the Shapeoko is way less maintenance, more reliability, less tweaking. For example, I've had this for a year and a half, and I use it 4 or 5 times a week, way more than what's shown in these videos. And literally the only maintenance that I've ever done is just oil the ball screws and the linear guides, keep those clean. That's literally it. No adjustments and tweaking necessary. I should have done a water-cooled flush of the water-cool system for the spindle, but I just haven't. So that's really the only maintenance necessary. With some of these smaller machines, you're dealing with belts for the drive instead of ball screws or rack and pinion. Belts typically you're going to break a belt, or you're going to have something slip. You have more areas for adjustment, more areas for failure, versus something like this that has a, well, in this case, ball screws. This machine has a ball screw X, Y, and Z axis, which is nice, precise, and long-term stable. Do you find a 2-foot by 4-foot bed limiting, or is it just right for a one-man workshop making non-production / type works? So in my case, the 2-foot by 4-foot wasn't limiting when I got this. My shop space was limiting when I got this, so that was limiting my design mindset. I knew that I could, at that shop, I knew I could not fit a larger machine in there, so I knew that I had to stay within the constraints of this 2-foot by 4-foot cutting capacity. And when you're in that mindset, well, then it's not really limiting because you're designing stuff to fit in there. And I haven't really let myself think outside the box, I guess you could say, outside this cutting envelope, because I knew that that was a restriction that I could not get around. Now that I'm in this larger space with much more room, I am constantly thinking of stuff that doesn't fit on here. So it's kind of like a perspective thing. If I was in that last shop forever, then I would likely not be doing much thinking outside this 2-foot by 4-foot cutting envelope. But no matter what, there's always things that you can do that won't fit on the machine. What is the learning curve like? Well, there's two areas for a learning curve: software and then physically learning how to use the tool. Software, SketchUp. I have a lot of resources on learning SketchUp for designing. I think it is a very easy program that anybody can learn. And I think VCarve is even easier than SketchUp to learn. It's a very basic process. And all this stuff is, if it's foreign to you, if you've never used it before, of course it's gonna just sound like rocket science the first time you use it, just insanely crazy, whatever. But all of this stuff, and even with the machine, your best friend is repetition and testing and being able to get some experience under your belt, because you do it a few times and you learn it. It's very basic stuff. Using the machine, the same thing. Just getting out here and using it and screwing up and testing the limitations of the machine. That's how you can learn the most, the fastest. When I first got this machine, I tested the capabilities of this machine, really stressing it out, broke a few bits, and then also stalled the machine a couple times just to figure out what the limitations were. Of course, every time doing that, you're real close to the emergency stop button, but that's the type of experience that's really going to make you learn the fastest, is just getting out there and testing the limitations of it, testing the basic concepts, getting some experience under your belt. Very easy to do. Thoughts on this compared to a comparable alternative like Powermatic's CNC, Grizzly's new CNC offerings, or a kit like Avid CNC? So the first part of that, there's a lot of, I don't want to get into the whole brand wars stuff. I don't care about that. But as a consumer, there's a lot of these machines that look very similar, right? So this one, the Axiom CNC machine, these three that he listed, the Powermatic and the Grizzly, they look very similar. The specs are very similar. I think we are in a day and age where, as a consumer, it's really nice that there are very few bad options. There's so much competition out there, which is great for us as the end user. But for the most part, just about all of the options are good options. I mean, that's a great thing to have. I don't have any experience with the Powermatic or the Grizzly, but they look very similar. So what are my thoughts on them? I mean, at that point, you're almost picking and choosing a company that you want to work with as far as support goes, rather than the machine, because they can pretty much do very similar things. And the last part there was a kit like Avid CNC. So that is in a different category because it's a kit versus a turnkey solution. So no matter what, if you buy, for the most part there, if you buy a kit that you assemble versus a machine that is a turnkey setup, you just set it in place and use it, your capabilities, your money is typically going to go further. Your end result capabilities are typically going to be greater with something you assemble because you're not paying for assembly. So you're going to pay for, that money is going to be pushed further towards capacity. So that's also something you need to consider is how much work you're willing to do to get up and running. Do you find that you need to stop and change bits all of the time, or you can do most of your work with one type of bit? This is just a general CNC question. So for the most part, you have one style of bit for profile cutting, profile and pockets, and that is an end mill. And then one bit size or shape for detail work, like signs, visual work, and that's a V bit. And then of course there's all kinds of other options for just various bits to keep in the tool arsenal, or your tool library is what it's called, like a flattening bit, various different shapes of V bits, ball nose bits. But for the most part, I would say 90% of everything that's cut on this machine is done with an end mill, like a 2-flute spiral upcut or downcut end mill or a compression end mill. And then some other like V carving work with a V bit. So changing bits is almost a necessity for most projects, but it's not that long. I mean, it takes the exact same amount of time to change a bit on this as it does a router table. It's basically a router. I'm considering the Axiom Iconic and wondering how much better results and use are with this one to justify the thousands of extra dollars. Do you have any issues with tool marks? I don't have any issues with tool marks, but if you do have tool marks, then you may or may not have the feeds and speeds correct, or your spindle may be off on one of the axes. You may need to tram your spindle. So that's easy to do and easily adjusted with any CNC machine. I'm not familiar with the Axiom Iconic, but I'm guessing it's a little bit lower end than this one, because this one you said is a few thousands of dollars extra. Again, you're paying for speed and reliability. For the most part, like I said, all CNC machines, all CNC machines can accomplish the same task. It's what you're paying for is low maintenance, reliability, speed, and long-term stability of being able to do things without you having to work on the machine. Do you ever use it for flattening stock or solely for shaping pieces? I've used this dozens and dozens of times for flattening stock. It's basically a jointer and planer, slower than a typical jointer and planer, because you do have to go back and forth and travel along the entire surface with a smaller cutting area than, say, a jointer and planer. But it can be done, and it's an extremely handy tool in that regard. So again, pretty much all CNC machines can do this, and you're limited by the cutting envelope and then also the power of the spindle. If you have a low-powered router, you obviously can't take off as much material as, say, a much larger spindle that can go faster through the material with a larger bit. Example that I've used quite frequently is flattening end grain cutting boards. I don't want to put an end grain cutting board through my jointer or planer, so flattening them on here, flip it over, flatten and plane the other side, flatten parallel. Very, very handy thing to have for those odd situations where this would actually be the better tool for the task. Also, one of the things that I'm looking forward to with my larger machine is I have a few nice, beautiful slabs outside that are greater than the capacity of my jointer and planer, and it'd be really nice to be able to flatten them with it rather than, say, a router sled where you have to manually move everything, which is plenty capable of doing that, but that's something I am looking forward to with a larger machine. What is routine maintenance like? Do you have to lubricate moving parts often? How do you take care of the water-cooled spindle? So maintenance is very basic on this particular machine. I do not cut without the dust boot running. I have a couple times just for video purposes, but that didn't last long because I hate chips flying everywhere. The dust collection is pretty good. So with it running, there's not much dust or chips that gets in places where it doesn't need to be. For example, the linear guide rails, and then the screws. You don't want to have a bunch of chips and stuff build up on those So for after every use, if you have crap up there, get it off. And as far as lubricating, every now and then I use just regular basic household 3-in-1 oil on all of the moving parts. Super simple. That's basically all the maintenance I do. The liquid cooled spindle, as I mentioned earlier, I haven't flushed the system that I think I'm long overdue. I need to do that. How about power requirements? This particular one is 10 amp, 240 volt circuit. And if dust collection is a must or a luxury, it's not a must. You can run this without dust collection. I like to keep a nice and tidy shop. I've had some bad allergy situations with my sinuses in the past, so I take a lot of effort to keep the shop nice and clean and tidy, and that means running dust collection on all the tools. Dust collection is pretty good with it. It's not necessary, but I highly recommend it. Does your computer hook directly to it or Wi-Fi or memory stick? Let me just bring you in closer and I'll show you the whole setup. Well, first, while we're at a wider angle, this is a little cart that I made, and these collet wrenches are gonna drive me nuts if I let them dangle, so I'll take those off. But this is a little cart that I made for the CNC machine. You can see the wires coming out the backside. There's one cord for the pendant, one cord for just a regular 120 volt receptacle via extension cord so that I could power my laptop over here, keep it charged up. And the pendant comes out over the top over here. I'll bring you in closer and show you. This particular setup uses a rich auto controller. So the controller, well, you obviously control the CNC machine. You control the travel. So you can manually jog it, you can manually control it, and then also you can run programs, which is where the CNC does its work. So this is not connected to the computer. I built this cart to permanently house my laptop, and a very old, underpowered by today's standards laptop that runs vCarve no problem. So you don't need a lot of high-end computer hardware to do this CNC type stuff, which is another bonus. So a little hole right here with a rounded over edge so that my mouse cord can pass through with no restrictions, comes through another hole over here to plug into the laptop. That's where the laptop power cord goes down, so it's not cluttered here on top and I don't have a bunch of stuff dangling everywhere. It's all enclosed on the inside. And of course, that's where the controller cord goes down as well. And this is all tethered to the CNC machine based upon the length of this particular cable for the controller. I do have a power cord zip tied, I think I said, that goes on the inside for some regular 120 volt power. So that powers my laptop, as well as a little cell phone charger over here. One thing that I will recommend for every CNC person out there is to have a fire extinguisher really close to the CNC machine. When I worked at Ashley Furniture in that production environment, obviously a much larger scale CNC environment, but there was fires that happened occasionally, and the way you're gonna get a fire is if something happens to the code or something happens to the machine reading the code and it just freaks out and stops, sometimes the machine will bury the bit into the workpiece and not move. So it's still rotating, but it'll bury it into the workpiece. So if you have a piece of metal spinning very fast, causing friction and not moving, builds heat, and will cause a fire. And I've seen several times where CNC machines catch fire because the bit gets buried into the wood. So also depending on the CNC that you have, the more reliability, the better components, the more reliable the machine is, the more you can trust it to work on its own without you babysitting it. That doesn't mean press start and go inside and take a nap for a long cut. But with a machine like this, I'm very comfortable starting the cut if it's a long cut and then working elsewhere in the shop. I can still see it if something happens. I can still hear it if something happens. But I'm not like outside, mowing the lawn or something like that. I would not necessarily not babysit it with some of the smaller machines that may not be as reliable and the software connection may be a little bit more flaky. There's that. Is the gantry rockable side to side? No, this gantry is not rockable. It is pretty stiff and stationary. I think the weakest link with my entire setup is the leveling feet. I literally just moved this here a couple days ago. So I haven't really gone through the leveling process of it and really lock down the legs. I just got it up and sitting in place. How long do tool changes take? Tool changes take as long as it takes to change a bit on a router table. Have you tried increasing feeds and speeds up to a failure point? Yes, as I previously mentioned, but I also keep these examples of doing so. So if you can read this, hopefully you can, if it focuses. This is a Whiteside 3/8 of an inch Hercules compression bit, cut at 157 inches per minute, 3/8 of an inch depth of cut, with a 0.205 pocket, a deep pocket, and the same results were with a 1/4 inch bit. So the pocket on the inside, minus the spot where the plywood failed right there. All of the cut areas are nice and clean. This is a profile cut with the exact same setup, nice and clean, minus these tab areas that I never cut off, so disregard that. But the cut is nice and clean, and this is a nice example piece to keep on hand for what this machine can do. I recommend testing this when you first get the machine. So plywood, absolutely no problem. Well, how does it do in a really hard piece of wood? So this is hickory, which we all know hickory is some tough stuff. A 0.262 depth of cut, 19,000 RPM, 157 inches per minute, 0.250 upcut Whiteside bit. And it cut really good, but you can see these lines right here, right? So that is one of two things. It's either the spindle not being perfectly vertical. It could be a little bit off and you'll have to trim the spindle or level that out. But the reason I concluded it wasn't that is because it's in both directions. If the spindle's off on one way, you're gonna see lines in one direction of the cut, not both sides. So I got the lines over here and over here. And what that tells me is the bit itself was deflecting. So that 1/4 inch bit, 250 Whiteside upcut bit, is not strong enough to produce a nice clean edge moving that fast in this dense of wood. So there's a lot of variables. The density of the material you're cutting, the RPM that you're cutting with, and the feed rate, and the depth of cut. All of those variables can drastically change the outcome of, or the result of your cut. So very capable of this, except I think I was moving just a little bit too fast for this dense of material on a 1/4 inch bit. So how does that fare with a really hard wood? This is Bubinga, even harder than hickory if I'm not mistaken. So all of this was cut with again, a Whiteside 3/8 of an inch Hercules compression bit. This is a 0.375 depth of cut. And these edges, unlike the last example I just showed, are indeed 100% flawless. There's no, I don't think there is. Let me put it in the light where I can see a reflection. There's no ridges or tooling marks where the bit is deflecting. The only downside is, well, it is a 3/8 of an inch bit, so you are removing more material, and depending on your profile, you're going to be stuck with that radius on your inside corners. So again, really nice to have some of these testing blocks as example, to do some testing like this and keep them on hand as examples of what your machine can and can't do. Oh yeah, this is 100 inches per minute. I remember cutting this at a faster rate, and it stopped the machine. It just completely locked up. So I think I did reach a limitation on cutting this faster with that size bit. Still pretty impressive. That's no joke with this Bubinga. How good is the dust extraction? I think the dust collection is really good, but it's not perfect, and that's just because this is a very basic dust boot that they offer for sale. It's not crazy specific. You can really force the air on a certain location if you really want. And what I mean by that is, for example, if this is doing a V-carve cut, no dust on the surface, perfectly flawless. If this is doing a pocket cut, large pocket, no dust, flawless dust collection. If this is doing a deep profiling cut, for example, a 1/4 inch end mill, cutting 3/4 of an inch in depth at a 1/4 inch depth per cut, and the bottom cut, if you're using a down cut bit to produce a better edge on the top surface, that bottom cut is probably going to have the dust packed into the groove rather than extracting the dust. I think that's acceptable. I've seen a lot of people, not a lot of people, 3 or 4 people online, mainly Instagram, send me a message saying that that can be eliminated by redesigning the dust boot so that it's really, because what it is right now, the dust collection is in front of the router, and it's kind of like a big open air that it's sucking dust out of. If this is hanging off the front side of a workpiece, you're going to lose a lot of air suction from around there in this wasted space rather than where the bit's at. So if you can create a dust boot that focuses the suction right around the bit rather than the wasted space in the front, you can increase the dust collection. People have said that doing so will produce clean profile cuts at deeper cuts with basically the same amount of suction, just relocating it right where the bit is. I've never done that. I still think I got good results without that. What is the tallest you needed to carve on this machine? Is the tall carving capacity something to consider when buying a CNC machine for things like you do? I have ran into the height limitation one time, and I got around that by just shaving a super tiny amount off the bottom of what I was working with to bring it down within specs. What I was doing was creating a projectile. This is a very specific case, which is another fantastic application for CNC stuff. I was creating a projectile for a wooden mortar that housed a GoPro on the inside. So we were going to fire this projectile out of the mortar with a GoPro filming from the inside. And if I have the footage, I think I still have the footage, I'll post it, I'll put it on the screen.
Ready. Fire!
Basically, I had to turn a cylinder on a lathe, chamfer the top edges, and then put that underneath the spindle with a very not that great clamping situation, and cut out a pocket for the GoPro to fit snugly inside. And then I also used the machine to cut out a precision piece of plexiglass to go around it, which was really nice. All worked out so great. That's one of the great advantages of a CNC machine, is like for crazy odd tasks like that, it is such a problem solver. Absolutely fantastic. This is an interesting question. How can you work with the panels larger than the bed? It looks like it might support some pass-through, or at least work that is one end and flip. What additional things should we keep in mind with such a system? Good question, because just because this is a 2 foot by 4 foot cutting envelope doesn't necessarily mean you are limited by that cutting envelope in both directions. In one direction you are, because the fixed distance between the posts of the gantry, that can't change. So you are limited with that. But you can pass material through. In my case, I have this overarm dust collection, so I do limit some of my pass through on the back side of the machine. However, everything is open to the front. So when I made my current assembly table, it is a 4 foot by 8 foot table, and the top is split into two 2 foot by 8 foot sections. So what that allowed me to do is slide the 2 foot by 8 foot piece 4 feet onto the table with 4 feet hanging off this side. And I indexed everything with a couple stop blocks on the side of the machine and on the back of the machine. So once I made my dog holes, my cuts that I needed, I took that panel, flipped it end for end without rotating or twisting it, so that same edge would be referenced off of the same stop blocks, cut everything else on that second side, and in doing so, I still maintained CNC precision in my Y direction, with all of these holes lining up perfectly with these holes. So you can pass material through, you can hang it off to one side and cut larger stuff. So that particular cut was a very simple cut because it was just a grid of holes and everything had to be referenced off of stop blocks. Very simple to keep everything super aligned. That's not the easiest thing to do if you're, say, cutting, let's just say you're cutting a 6-foot arc, right? Well, you don't have 6 feet, so you have to pass it through. And the cool thing that can happen there is the software allows for tiling. I've never done this before. I haven't honestly never looked into it, but I know the feature's there. And a friend of mine, Jonathan Katz-Moses, has implemented that before on this exact same machine. So I know it's capable. Basically what you do is you secure the material, and the machine drills certain location dowel holes that will allow you to cut half of it, pick the board up, pass it through, and register once again on those dowel holes. And at that point, it knows that you've moved it at a specified distance, and then you can start the second half of the program to connect the rest of the geometry. So that's really cool and really fascinating. That software is allowing you to overcome certain limitations that the hardware has. Love to hear your perspective on size. I'm 5'6", and I've never had to get anything off the top shelf for anybody. Which router bits do you find most useful? A 2-flute end mill is basically the most commonly used bit. Do you have the water-cooled spindle? Yes. I need to flush the system. If you create something in SketchUp, can you import it into vCarve? Yes. Just drag that file right into your vCarve, and you have several different options to drop the vectors in place. Have you ever considered using it for Intarsia projects? I think I'm pronouncing that right, Intarsia. I imagine the accuracy would be very beneficial. I have not used it for Intarsia, but Intarsia, if I'm not mistaken, has 3D type of cuts that are rounded over on the edges, so you have different wood species to represent different parts of the image, and then they're rounded over to blend, kind of almost like a three-dimensional puzzle fitting together. Very beautiful technique. You would be limited on a CNC machine cutting out those 2D profiles by the diameter of the router bit you are using. For example, if you need a perfect 90-degree inside corner, a radiused router bit can't make that cut. So for Intarsia work, maybe it could be beneficial, but I could also see the limitations of it. And then once you have the pieces cut, then you just shape them as necessary for them to visually fit together as the way you want. But as far as that same concept, you can do vCarve inlays, and what a vCarve is using a V profile bit to make very precise shapes and cut vectors out on your material. So if you have a perfect inside corner, for example, I'll show on the screen a MSU end grain cutting board that I did. Those are nice, tight, precise outside and inside corners because the software tells the machine where to lift the V bit in that corner, so you result in a nice, perfect 90-degree corner or sharp corner. So Intarsia may be beneficial, but very limited. That same concept of having contrasting woods can be executed very easily and very precisely with vCarve inlays. Did you receive training on the software? No. I'm of the mindset of I don't like not knowing something when it gets stuck in my head. So if I don't know something that I want to know, I research it intently. And all of this information is so free and available on the internet. And then also, just about all of these companies do very well with documentation. So you can always read user manuals for stuff for the software to learn how to do certain tasks. But basically, just watch it on YouTube. There's a lot of good resources out there for learning software. That's pretty much all the questions that I had on this machine. The majority of them are repetition, the same questions over and over again. And I feel like this video is going to be really long anyway. I do want to show one feature that I absolutely love about this particular setup. And then it would be, I got to find something that is at least a little bit of a con or a little bit of a downside with this system. So I'm gonna be nitpicky and try and find something, but overall, like, I've had nothing but a fantastic experience with this machine. So I'm gonna try and find something. By far, my most appreciated feature, the most convenient thing that this setup does, in my opinion, is it has programmable origins, up to 9 different programmable origins. So real quick, for somebody who doesn't know much about CNC machines at all, the machine has a home and the program has an origin. So the program is actually what you create on the computer. The program is that file that the machine reads to cut whatever it is that you created. So the first thing that you do when you start up your machine is you always home the machine. So in this case, what it does is it puts it to the furthest left, the furthest front, and the furthest up direction. So a value of 0 for X, a value of 0 for Z, and a value of 0 for Y. And in this case, this machine is right into this lower left corner, which is very typical and very common of CNC machines. So there's magnetic limit switches. When this machine runs this operation, which should happen, again, the very first thing you do every time you start the machine, what it does is it disregards all of the values of where the machine is, where the cutter is. It's a coordinate system. X value of 5, Y value of 10. It's a precise location. It completely disregards that and goes into the position to where the limit switches stop the travel. So there's, if I'm not mistaken, these are magnetic. So it goes into where that switch is tripped, and at that point it knows in space that's physically 0 in that direction. So now it is at 0, 0, 0, and everything that it ever does is based upon a relationship between that location. So if you need to cut a 10-inch rectangle that starts at 10, 10 in the X and Y value, it first needs to know where 0, 0 is in order to make that particular cut. So that is the home position. In the software, you can specify your origin, which is very similar to that, but it's the software side of things. So for convenience sake, I typically keep my origin in the software 0, 0 at the lower left-hand corner of the screen, or lower left-hand corner of my cutting area, and then work from there, because I have programmable origins on the exact machine itself. So you can start from the machine home, or if you say, for example, this machine home is way up here into the front side, and in doing so, you don't have much area on the front side for clamps. So for all cuts, that may not be convenient, and you may want to push it further forward like I have here, this piece that's already clamped down, so that you can have a full access of these clamps. So that's what I did when I first set this machine up, is I programmed a couple of convenient origins for me to use frequently. So for the vast majority of everything that I cut, I don't start at 0, 0 on the machine. I start at 0 in the X and 6 inches in the Y. So what I've done is I can change my origin here by pressing menu 2. Now I'm at the second origin, and I can go to that exact origin location every single time, very repeatable, and it's stored on the controller. Something else that I did when I first set this up is I used a V-bit, a 30-degree pencil point V-bit, to cut a 2-inch by 2-inch grid, very shallow grid, throughout the capacity, the physical capacity of this machine. So at any time, if I know that I want to start my cut at origin number 2, which is at 0, 6, I don't have to measure every single time. I just look at my grid system, line everything up with those perpendicular lines, clamp it down, and I know that I'm starting right at that origin. And from there, I can run my program that I created on the computer that starts in the lower left, which is now at 0, 6. For example, or another example is if I need to clamp on the side of the material instead of just the front and back, then I obviously don't have a lot of material on the left side according to the camera's orientation. So for that, I programmed number 4, which starts at an X value of 4 and a Y value of 6. And again, it's programmed in here, which is very easy to do. So menu 4, I'm doing this upside down, I can't see. Menu 4, and then go to the home position, or not home position, the origin. And now I'm at that repeatable point every single time where I can start this particular cut if it's specific to that particular location. And you don't have to start from those lower left corners. You can start from the center of your material. For an example of that would be, I have something saved in here for a 4-inch keyhole slot. You don't need 4 inches of a horizontal keyhole to hang something, but it's super convenient, kind of like a fits the bill of everything, large and small stuff, to just have one file that accommodates all of that. So for that, you want to run it off of the center point, or the origin needs to be at the center, not the lower left, because you're going to be cutting that on all kinds of various different shapes, different size items that you want to hang up. So for that, you can go to any one of the unused origins or unused program saves, origin saves, so you don't mess those up. So I typically go to origin number 7, and at any time you can jog the machine, clamp the material down, jog the machine however you want. So now the bit is perfectly where you want to have that keyhole slot, and from here, it's just one button to clear your X and Y and tell the machine that now where I physically put this, that's where the X and Y should be 0. And because the keyhole slot cuts with 0, 0 in the center of that program, it'll start the keyhole slot with that keyhole centered right where I put it. So having programmable origins, I'm sure there's other ways to do it on other software, but for this, it is so convenient, so easy, and so simple to understand with the interface that you're given. All right, time to get on the floor. I've got the camera set so you can see the VFD, variable frequency drive, as well as this little cheat sheet up here. This number right here is controlled by this dial, and the readout here, you multiply that by 60 to get your spindle RPM. So the spindle RPM is not automatically controlled with this setup. It is still a manual control. And if I was to be completely nitpicky, because this really doesn't matter, this is not an inconvenience, I would like to see that this controlled by the software. So just trying to find something so that this is not a huge glowing tools are awesome kind of video. It'd be cool if this was controlled by the software, which VCarve does export the spindle RPM, but this doesn't read it, obviously. It's manual controlled. For the most part, I keep this around 12,000 RPM for my end mills. Faster is not always better. Faster bits scream. That screaming you're hearing is rubbing. Rubbing causes more friction and heat buildup, which dulls the bit and causes premature breakage of the bit, decreases the lifespan of the bit. So you don't want to be running too fast, but if you're running too slow, you're obviously going to break the bit as well. So there's a sweet spot you need to find for your RPM, and what you need to do is look up a chip load calculator based upon the geometry of the bit you're using. So once you find a chip load calculator for your bits, then you can input your RPM that your travel speed that you are trying to achieve, and it'll tell you a recommended RPM for a recommended chip load. So you're trying to get an optimal size chip and not dust when you're cutting. But it'd be really cool if this was automated with the software rather than a manual control. Such a minor thing though. I imagine this video is going to be pretty long. It feels like it's been long since I started recording this. So if you've made it this far, kudos to you and thanks for sticking around. I will close it out by making 2 recommendations, and those recommendations are for you to look into. I'm not going to recommend anybody purchase anything. I don't like other people telling me how to spend my money. I sure don't want to tell other people how to spend their money. So from that, I do think though that I can make a recommendation or a set of recommendations based upon information and experience, just a logical recommendation rather than an emotional recommendation of like, hey, I got this new tool, I still have the new tool high, it's amazing, I love it, love it, love it, and you should buy one too. Which is what I see a lot of out there, which kind of sucks. So the first decision you need to make 2 decisions. First is, what is your cap budget? What is the maximum budget you can possibly spend on this purchase? Because ultimately, any recommendation that's over budget is completely worthless because it's over budget, you can't afford it. Makes no sense whatsoever. So determine your maximum budget, your maximum cap, and just get your motion out of the way and completely eliminate anything you can't afford. There's a lot of stuff that I can't afford, and we all know how that goes. So that's number one. A little side note to number one, I personally recommend staying out of debt. I'm an anti-debt kind of a person, and my business was started with an initial $200 investment from personal income that I very quickly paid back. And then since then and going forward, my business has been and always will be debt-free. So just from a little personal caveat, try and stay out of debt. So once that is determined, the second decision you need to make is, are you willing to assemble yourself, or are you wanting to purchase a turnkey setup? Because that drastically changes things. That's a huge line in the sand. I know a lot of people out there are really of the DIY mindset to stretch their money as far as they can by buying components and assembling stuff to get the larger capacity and have their money go further, and they're having a little bit of sweat equity involved. And I know there's a lot of people out there who don't have the time for that, or just simply have no desire for that, and they would much rather spend a little bit more in comparison of capabilities and specs just to get a turnkey purchase, which is something like this is. So really make a hard decision on which one you want in that regard, because that can narrow things down quite a bit. And from there, there's two recommendations that I have. Now, when I got this machine a year and a half ago, shortly after that, within a month, I think I developed a copy and paste reply for emails of commonly asked questions, because shoot, I think 200-300 emails since then have been about specifically in-depth questions about CNC stuff. So from there, it was really easy to say, hey, I got a copy and paste reply for this, because it's just kind of very, very common. So then I would reply with that. And in that reply from over a year ago, I still had the exact same two recommendations. And that is, if you're looking for a turnkey setup and all of your sizing requirements are met with the Axiom lineup, then based upon my great experience with this machine over the past 2 years, all of my expectations have been met or exceeded. I have no problems recommending people look into the Axiom lineup. I'm extremely pleased with what this machine what I was able to do with this machine. Extremely pleased. My second recommendation for over a year now was that if you are wanting to stretch those dollars further, do a lot of the work yourself for the assembly, then look into the Avid CNC lineup. Avid CNC, formerly CNC Router Parts. Now, while I don't have any firsthand experience with those machines, I know a handful of people, 3 people personally, that do have those machines and have had great feedback from them. So with that information, also with the information that I've learned just from researching stuff, the ability to completely customize the machine, to have the machine built around your needs, there's something to be said about that. So with that said, my 2 recommendations were look into the Axiom and look into the Avid CNC lineup. My next CNC machine will be, based upon my previous research and recommendations from others, the Avid CNC. I'm building a 4-foot by 10-foot machine. A lot more on that in the future. Hopefully in a year or so, I'll do another video like this on that machine. But that's basically all I've got on CNC stuff. Determine your budget, determine the work you want to do, and check out these 2 lineups. I'm sure there's a lot of other really good options, but that's just based upon experience and research. I feel like I need to drink something. I've been talking quite a while. So you guys take care, have a great day. If you have any other questions, leave them in the comments. Shoot me an email, get a hold of me in some way, and I'll be sure to answer them the best that I can. Have a great day, and I'll talk to you in the next video.